0.865. All right, so we're going to eyeball both of them, and we see that the lines, they are on the same horizontal line. There is nothing like sorting in ascending order. We cannot sort in ascending order. So we'll first of all do the scatter plots. So let's do the scatter plot, second start plot, and then I'll select scatter plots. It's already selected. I have L1, L2. Then I'll zoom 9. So when I try to zoom 9 and I see this, then I'll second quit. Then zoom 9 on the main screen. Before I do this, I will check that I need to clear my Y1. Then I zoom 9 again, zoom 9. All right, so when I eyeball my scatter plot, it looks like the line of best fit will have a negative slope. So because the line of best fit will have a negative slope, I already conclude that there is a negative linear relationship between the number of coolers per week and the bone mineral density per week. So there's a negative linear relationship between the number of coolers per week and bone mineral. Okay, so at this point we put in a line on it. So start, arrow to calc. Number 4 is linear regression. L1, the explanatory variable is in L1, so I need to make sure I change this. So this is second L1. Second L1. Okay, and then L2 has, I reviewed it the other day, but it's worth looking at again. So what are the properties? Okay, so that is here, right here. We want to make sure we come back here again and check it. So what are the properties of coefficient of correlation? Because it's already in the test, and the test is about the first week of October. Our unit 2 test will be first week of October. All right, so the first property number 1, the linear correlation coefficient R is between -1 and 1. Because I promised to review it again today, I want to make sure I say it again, where I can write it in interval notation, -1, 1. So that is the value of R cannot be less than -1, and it cannot be greater than 1. We are also supposed to know that R squared is called coefficient of determination, like we said yesterday. R squared is R times R. So if I square R, then the interval of coefficient of determination starts from 0. So I can also write R squared in interval notation. I can say 0 is less than or equal to R squared is less than or equal to 1. So the coefficient of determination can be 0, can be 1. It cannot be negative. Of course, you know why? Because if you square R, anything you square cannot be negative. So the lowest R will be -1, the highest R will be 1, the lowest R square will be 0, the highest R square will be 1. The closer R is to +1, the stronger. The closer it is plus -1 is stronger in a negative direction. Okay, let's see the other ones. So actually, coefficient of correlation has 8 properties. You will need to remember at least 4 of them in the test. If R is close to 0, then little or no evidence exists of a linear relation between two variables. So we can say if R is close to 0, so we say there is no linear relationship. That you cannot say no relation, because if there's no linear relationship, there could be quadratic relationship, there could be exponential, there could be logarithmic. So there are so many regression models, but the only one we are doing now is linear regression. We are doing only linear regression analysis. Property number 7, the linear correlation coefficient is unitless. We said that the other day. What does unitless mean? It does not have any units. Even if we know that the unit of L1 is still feet, and unit of L2 is feet, the units of both, when you finish it, the answer for coefficient of correlation will be, if your answer is 89%, it's just 89%. There is no unit. Property number 8, the correlation coefficient is not resistant. It's not resistant to outlier. That's what they're trying to say. So what does this mean? Correlation coefficient is not resistant to outlier. This means that any small outlier will affect coefficient of correlation. Any small outlier will affect the coefficient of correlation, just like standard deviation and the mean. Okay. All right. So we will now go to our test. First of all, let's see how to calculate residual. So there will be a case where they'll ask us to calculate the residual. So let's see. Sometimes they can ask us to calculate the residual. So let me see where the question says find the residual. And we need to talk about it now. Find the residual. So we have this data here, and we want to see where we are told to calculate the residual. And by the way, when we talk about the residual, whenever you are told to find the residual is the observed minus predicted. Observed minus predicted. So actually what does it mean is when you come to that table, so the predicted is the one on the line, and this is the observed. So if I'm looking for the residual for 102, I can draw a line like this. So the 102, this one here, the point here is the below the line is the observed, and the point on the line is the predicted. So whenever you're told to find the residual is the difference between the observed and the residual. And by the way, notice that observed comes first. So if the observed is under the line, then the residual is negative. Right here, the residual of 100 is negative. Why? Because the observed is under the line. All right, so let me see the residual. Residual for 101 will be positive because the observed is on top. The point you plotted is the observed. The point you plotted is the observed. So the observed minus predicted. The predicted is on the line. So you notice that the distance from here to here is going to be positive. Why? Because the observed, the scatter plot, is at the line. Also, residual when you see 105 above on the line, so notice that there are two 105s there, though. 105 things. Anyway, so if I find the distance between them, one 105 has a bigger number. If I find the distance between them, I have the residual. So residual is going to be positive because the number, the scatter plot, is above the line. Here again, the scatter plot for 100 is above the line. So residual here, right here, is going to be positive. All right. So the residual for 99 will be 0. Why? Because the observed and the predicted are the same point. The observed and predicted are the same point. So the residual is on the line. Let's look at the table. You can use a table to do this. So let's get a table. Let's first of all see an example they did for us. And by the way, the equation we calculated, let me get a calculator. The equation we calculated is called the least square regression line. The least square regression line. And so if I'm told to write that equation, let me the equation of the least square regression line that we drew right now. Let me just take a picture of that so I can, it's not going to run away. Okay, so I have y. This is called the predicted. Y is the hat above it. A y with a hat is called the predicted. The predicted y. Okay, the slope is b1. So I'm going to get b1 again. So what is the slope? Slope is negative 0.003. Negative 0.003. So negative 0.003. 03. And that is 3x, 003x plus. So let's see if b is plus. What is b? I'm going to make it bigger now. Let's show that. So let me make it bigger. All right, so what is b from my calculator? The b from my calculator is 0.886. 0.886. All right, therefore, the equation of the regression line or the equation of the line of best fit or the least square regression line, anyone, they are all the same thing. The least square regression line or the predicted equation or the line of best fit is negative 0.003x plus 0.86. The regression equation has a negative sign. In other words, the slope is negative. Therefore, the coefficient of correlation will be negative also. I want you to know that they could actually give you a formula where B1, the slope, is R multiplied by the standard. This is coefficient. If you use a z-score, then you have sy of x. So now we have is the slope of the least square regression line. So this is the slope. This is the slope of the regression line. All right, so if you are told to find 0, this 0 is always the y-intercept, and that is equation. But guess what? I don't really think you need to do that. If you have a calculator and you're to be told to find the y-intercept, so find the y-intercept. All right, so this is the least square. Okay, formula and plug in. The formula will be given to you anyway, and the formula sheet maybe will be there. I'll give you a formula sheet. And by the way, the formula sheet is in Blackboard, so when you're taking the test, then you can use the formula there and plug in as required, as needed. Okay, the formula will be given to you. Okay, and if you're told to calculate S, you'll be given to calculate R, use your calculator, please, because it's a long formula. If you're told to calculate R squared, use your formula also, use your calculator also. All right, so if you are told to interpret the predicted value of this, notice that there are two different y's. Be careful. The first y is the observed. The y with the heart is the predicted. It is an estimate of the mean value of the response variable for a particular value of the explanatory variable. It is an estimate. So the observed is an estimate of the value of the response variable for the particular value. So, all right, so we can use technology, and we already use technology. This is another one. So this one is another equation. Let's see. Let's arrow up. So what do you try to use your calculator to find the equation so that you don't make mistakes. By the way, if you have 20 questions and you decide to do it by hand, that's going to be a lot of I don't really want to make a mistake. So we can be told to calculate the residual for each and every one. For each and every 1 point, calculate the residual. All right. So anyway, so we are comparing the two things given to us. So this is the club head for the first equation. Second one, example, this is the equation. Whenever you're told to calculate the residual, then you know that this is your predicted. Y hat is the predicted. The Y1, the first Y is the what you're given. So what am I supposed to do now? This minus this one minus this. 257. This is the original Y. So I'm going to write Y there. And this is the predicted. You already see it is predicted. The observed minus predicted is residual. So subtract this from this, and you get these individual numbers. Then square your residual, square each of them, okay? And then when you square each of them, you add them up, then you have the sum of square residual. Some questions in the test will ask you to find the sum of the squared residual. So I'm going to go over it again. How are you going to find the sum of squared residual? I'm going to say it again. So if you're told to do that, you make a table like this. So remember that we are comparing these two. So this is your Y, the original Y. The original Y is the observed. The Y calculated from your calculator is the predicted. How do you calculate the residual? Observed minus predicted. And what does it mean? For each observed, subtract the corresponding predicted. For each observed, subtract the corresponding predicted. You know what? Let's get so you understand. Let me just get a calculator. So I'm going to get a calculator and let's just practice this with that. This is what people don't like in the linear regression. So I am going to go to start. By the way, the equation is still in y1. All right. So this equation in y1 is my predicted equation. The value of y in L2 is the observed. So the value of y in L2 is the observed. So now I am going to put the L3, my predicted, in L3. So what I'm going to do is substitute each corresponding value of L1 into that. So I can say, watch how I'm going to do it. How do I get the residual for each of them? I will just say, now that I have arrowed my to this, what I'm going to do is L3 is equal to, it's already here, equal to L2, actually my equation y1, I'm going to put y1. So what is in y1? Verse function y1. So that is y1, substitute my L1. So I am substituting my L1 in that equation in y1. When I finish that, it's going to put all the residuals. For each and every one, all the residuals will be in L3. So let's do that. You see, all the residuals are in L3. So what did I just do? Let me just make it simple. F of 0. So if I do f of 0 is the same as substitute 0 in that equation. Substitute 0, that's a function of a function. Okay. Substitute 0 wherever you see x, that's what it means. But what I did is that in that data, let's go back to that data, by the way, so that it will make sense. Or I'm just doing it here. But anyway, so I substituted 0 for each corresponding number. I substitute 0 for the equation in y1, and I got all the residuals. So these are the residuals. And now I am going to square all the residuals in L4. So in L4, I want to tell my calculator to square the residual and put it in my L4. So what I'm going to do is instruct my calculator to pull all the L3 and square it, square each L3, and I'm going to hit enter. So now I have squared all the residual. My residual was in L3, so I just squared each of them. Okay, so now I am ready to add all the residual up. Of course, you know, notice that it was added up. You can do it by hand though. You can do it by hand the way they did this one. And if I want to add them up, I can just go to the main screen. I'm showing you how to do it with calculator, but you can do it by hand. Everything should not be done by a calculator. So I'm just going to go to second quote, and then my residual is the sum of the square residual is in L4. So what I'm going to do is, for the data that I just did, I want to sum L4. I want to sum all L4. If I want to do sum, I go to catalog. Anything can be found in catalog. So the sum of the square residuals I can find in L3. So I'm going down, sum, looking for sum. When I get sum, I will pull it to the main screen. So I'm looking for SUM. Found it down. Then I'm going to tell my calculator that I want to sum L4. I want to sum everything in L4. Hit enter. So the sum of the square residual is 11.491. Okay, you will be told to calculate this though. You can decide to calculate with a table like this. The table is long, or you can use a calculator. This is the table. All right. So now what those videos, or you can come back and watch the class video. So we're doing another example. Example 3. Find the linear regression equation, or find the line of best fit that fits the explanatory variable. The explanatory variable is X. The response variable is Y. So what I'm going to do is pull my calculator and then clear, go to start, and clear every list that I'm not using. So I'm going to clear list 4, clear L3, I'm not using it, clear L2, I'm not using it. So clear, enter, and clear L1, clear L1. Okay, remember that X is called the explanatory variable and Y is called the response variable. So I'm about to plug in, put in the data in X in L1. So 2, enter, 4, enter, 5, enter, 8, enter, 9, enter. And then I go to L2 and enter all the variables. So 3, enter, 2, enter, 6, enter, 5, enter, 8, enter. Okay, I have to eyeball what I just put in. When I eyeball what I put in, you see they are all on the same horizontal line. Also, there is no sorting in ascending order in linear regression. We cannot sort in ascending order. So the first thing we do is do a scatter plot. Do a scatter plot. Select plot 1. And then keep on going. I select scatter plot. It's already selected for me. I'm using L1 and L2. So I can do scatter plot right now. So zoom 9. Okay, I tried to zoom 9 and there is this argument. So I second quit. So what is wrong with you? Well, I think it's frozen. Actually, it is frozen. All right, I'm going to X out. My calculator is frozen. All right, I'm going to pull it up again because it is frozen. Okay, I'm going to pull it up again. Hopefully this time it will not be frozen. Okay, now second quit. Hopefully it's going to behave. All right, so I want to make sure that my data is still in L1 because, okay. All right, so now I pull up my Okay, I pull up the table. So I'm going to do scatter plot again. Second scatter plot, plot 1. And then I am just going to zoom 9 because everything is in order. So I'm going to zoom 9. So I am going to second quit, zoom 9 on the main screen because I had that argument. So when I eyeball the scatter plot, I see that they are not, the scatter plot are not on the same line. But anyway, even though they are not on the same line, I can see that the line of best fit will be a straight line. So I'll just, the line of best fit is a straight line. Okay, so I can already say that the two variables have a high positive linear relationship. I cannot say perfect positive linear relationship. So the next thing I want to do is put a line on this. Put a regression line on it. So start, arrow to calc, select number 4, because I need linear regression. My L1 is my L1 is my predictor variable. My L2 is my response variable. The frequency is 0. Linear regression, I want the equation in Y1. So vars Y vars function Y1. Okay, so I'm going to calculate. So I think everything is in order. I'm going to tell my calculator to calculate the regression equation for me. So I hit enter. So that is the regression equation. If I pull Y1 up, it is there. So I can go ahead and start answering other questions. So, but this time, let me, so we are going to, this time I'm going to take a picture of it again. We will try to do another residual using this data. This data is smaller. Hopefully you will understand this one. So we're going to do a residual again, calculate the residual. But anyway, if I push graph or zoom 9 again, the line that I just graphed, the regression line is on the data. I can see that the line has a positive slope. If I push trace and arrow down, you see that the equation is here. So I can get that equation from here. Okay. Now I will be calculating the deviation from the point to the line. What is the distance? What is the deviation from the point to the line? What is the deviation? What is the deviation? What is the deviation? That's what is the sum. Of course, I know that the residual here is negative by me looking at it because the point is below the line. So residual will be negative. The residual will be 0. This point is on the line. The residual is negative here because the point is below the line. The residual is positive here. Remember, the residual is observed minus predicted. The line is the predicted line, so observed minus predicted. Observed minus predicted will be positive. Observed minus predicted will be positive. So okay, now we can find the residual of each one of them. So if I'm told to find the residual of each one of them, okay, we have the equation. Let's actually write the equation here so that you know what I'm saying. Let me make sure that. Okay, so the equation is y. The equation is y equal to, by the way, y hat. The y hat is equal to 0.065x plus 1.157 Okay, suppose I am told to find the residual for 2. I will find the residual for 2. The residual for 2 is the observed for 2. So residual for just 2. Residual for 2 is observed. And what is observed? Y, the given Y, observed minus predicted. And how can I calculate this? I already know that the corresponding value for Y for 2 is 3. So I'll write it down here, 3. So 3 minus, then I want to find the predicted. Okay, watch it. The predicted is going to be 0.065. Whatever I see X, I put 2 there in my new equation, the equation I found, plus, so this is just like function of a function. Okay. Okay. All right. So what I'm going to do, and by the way, I am going to use parentheses, bracket, whatever you call it, because I am subtracting the whole predicted from the observed. So I can just do it manually. I can get my calculator quickly. So you understand that it is, whenever you're told to find the observed for each of them, you do it one by one. But if you're told to find the observed or the residual for all of them, then you do it for this, plus residual for this, plus residual for this, plus residual for this, plus residual for this. Then square all the residuals and then add them up. And when you finish, it will be called the sum of the squared residuals. When you finish, it will be called the sum of the squared residuals. I hope that makes sense. So I'll get my calculator and get just the residual for 2. I'm just getting the residual for 2. All right, so it is the corresponding value of 2 is 3. So 3 minus parentheses 0.065 multiplied by 2 plus 1.157. 1.157 close parentheses and then hit enter. So the sum of the, actually the residual for 3, I mean for 2 is 1.713. Okay, well, let's eyeball the graph again. Let's go back and eyeball the graph. If I zoom 9 again, I see. Zoom 9, I'll see how it looks. Okay, so this is 2 here. So the 2 is outside the graph above. That is why the residual is positive. The residual is positive because this dot for 2 is above the line. When we calculate the residual for 4 now, it will be below the line. So by the way, let's calculate with our calculator so that you know there are so many ways you can do it. So if I want to use my calculator to do what I just did here, all I have to do is tell my calculator to put the value of y. So vars, y vars, function y1. I'm telling my calculator that equation in y1, please substitute 4 for me. Substitute 4 for me. So I put 4 there. I want to know the residual for 4. The residual for 4 is 3.761. And by the way, Um, okay, did I subtract that? Anyway, I just subtracted. Okay, I see. So that is, I plugged it in, I got the number, then I will subtract 2 minus, because observe this 2 minus whatever my answer is, second answer. Okay, well, let me do it again. I want to do it over function y1, and I'm going to substitute 4 there, close parenthesis. If I hit enter, I'll do that again. Okay, first function y1, I want to substitute for wherever x is. So I hit enter. All right, so this is predicted. So what is my observed? My observed is 2. So 2 minus 3.761 minus 3.761. Therefore, the residual for 4 is negative 1.761. All right. So I can keep on doing them one by one until I get a residual for each one of them. And I get you, I bet you get what I'm saying. And when you also watch the video and read the PowerPoint, you get it. So each of them, you could be told to find the individual residuals, or you could be told to find all the residuals, square them, and add them together. You could be told to find the sum of the square residuals. Really, people don't like this question, but it's always going to be there. People don't like find the sum of the square residuals. All right. Okay. And I think we can stop here, and we're going to start with, when we come next time, if you don't have any question, ask your questions when you come here next time. Let me know if you understand how to calculate the sum of square residuals. Try it. It's not difficult. Try it in the PowerPoint. Try to watch it